This is AB Calculus U Substitution Homework Help. I gave today an assignment that's due next Tuesday, March the 5th, of 10 U substitution problems. And I'm going to go over a few of these in this video lesson so as to make interested students more comfortable with what's going on. Okay, I'm going to do the first one I'm going to look at here. So that was 1 and 2. I'm going to go ahead and work out problem 3 here. Here we have the integral of the square root of 25x minus 1 dx. And we do not have the square root of just a single variable. And so we're going to use U substitution. So I'm going to say first, let this inner value, 5x minus 1, equal U. So, differentiating both sides, we're going to have 5 dx is equal to du. And dividing both sides of this equation by 5, we're going to have dx is equal to du over 5. And so we're going to replace this dx with du over 5, and we're going to replace this 5x minus 1 with u. Okay, now just coming down below and rewriting, we're going to have now the square root, we're going to have the square root of u now. Well, the square root of u is the same as u to the 1/2 power. So here we are writing u to the 1/2 power, and we're going to replace dx with du over 5. And working to the right, we're going to take this over 5 and convert that to a 1/5 out front. And the reason I like doing this when I can is to unencumber the integral and make it as simple as possible. So we have 1/5 the integral of u to the 1/2 power du. Now we're going to integrate. So we're going to take 1/5, and this u to the 1/2, we're going to add 1 to that. And so we make that u to the 3/2. And we're going to divide using the power rule by 3/2, which is the same as multiplying by 2/3. Dividing by a fraction is the same as multiplying by its reciprocal. And we, now having integrated, we use our constant integration. And now working below, we have 1/5, and I'm going to simplify the fraction further. We have 1 times 2, or 2 in the numerator, and in the denominator we have 5 times 3, or 15. So we have 2/15 u to the 3/2 power plus our constant integration c. Now we're going to take this value for u and substitute it in for this u here. And doing that, we have 2/15 I have 5x minus 1 to the power of 3/2 plus c. And we could write this if we wanted to as, we'll call this a final answer, but we could rewrite this 5x minus 1 to the 3/2 as the square root of 5x minus 1 cubed. So we could have written it like that. Anyway, next one we're going to look at is number 5. And what you're looking for is a quantity that you're taking the power of in this case is going to be a pretty obvious choice. So this is going to be our u. So we're going to say let u equal 3 minus 4x. And taking the derivative of both sides, we have du is equal to negative 4 dx. And dx is equal to du over negative 4. Okay, now making our substitution, we're going to let u be that. We're going to let dx be that. Let's go. I'm going to bring this 5 out front of the integral, working below. We have 5, and we're going to have u to the 2/3 power. And we're going to have times du over negative 4. And continuing working to the right, we're going to have, I'm going to take this negative 4 in the denominator, and I'm going to make that negative 5 fourths integral of u to the 2/3 power du. Now I'm going to work below. Negative 5 fourths. We're going to integrate now this u to the 2/3 du. So we're going to get u to the, and if we add 1 to that, it's going to be 2/3 plus 3/3. We're going to get 5/3. And we're going to divide by 5/3, which is the same as multiplying by 3/5, plus our constant integration c. Now just continue to work below. In the numerator, we have negative 5 times 3, so we're going to get negative 15. And in the denominator, we have 4 times 5, or 20. And then we're going to have u to the 5/3 power plus c. And I'm just going to work one last time. We're going to do this all at once. This negative 15/20, I'm going to convert that to negative 3/4. And this u, we're going to replace with quantity 3 minus 4x. And we're raising to the power of 5/3 plus our constant integration c. Okay, let's go to the last one I'm going to do is homework help, this 9. And this is one that I looked at initially. I couldn't readily see that this thing would work, but I determined that it did. We're going to take this value 1 plus 1 over x and set that equal to u. So we're going to say 1, let's say let u equal 1 plus 1 over x. Okay. So I'm going to rewrite this. I'm going to say let's say u equals 1 plus x to the negative 1 power. 1 over x is x to the negative 1 power. Now I'm going to say du is equal to, the derivative of 1 is 0. So we're going to have, use the power rule, we're going to have negative 1 x to the negative 2 power, or that's going to be negative 1 over x squared. dx. Okay. And solving for dx, we're going to multiply by the reciprocal of negative 1 over x squared. So dx is equal to du times x squared over negative 1, we'll say. I'll just make this whole thing negative. So now we have this quantity du times x squared over negative 1, or we could write it differently if we want to. Okay, let's do the replacement. Bring this down. We have u to the third power. Okay, and then we're going to bring this 1 over x squared here, just replacing that. And now we're going to replace dx with du times x squared over negative 1. Well, we have x squared over x squared cancel each other. So in these u substitutions, you're looking for something to cancel like this. Otherwise, you have more complications. If we still have a negative sign over here, so I'm going to bring a negative sign out front of the integral. And we have left u to the third power du. So it should be at this point a really simple integration. So we have negative u to the fourth power, and we're dividing by 4 plus c. And that is going to be equal to negative 1/4 u, and u is equal to 1 plus 1 over x to the fourth power plus our constant integration c. And so that's it. So basically, looking if you have something outside of the u quantity, you're looking to be able to cancel it. Like in number 10, if you take the derivative of this thing that's going to be u here, with that, are you going to be able to cancel x to the 1/3 power? Yeah, I think so. Anyway, I hope this has been helpful. Good luck, and thanks for viewing.